So far, we've looked at a range of properties from structural properties to thermal properties and electrical properties. But there is a price potentially for being able to choose materials with very high properties. And so part cost becomes a deciding factor in terms of finding a balance between can you sell that part at a price that customers want to buy, and what is the trade-off in being able to choose the best materials in terms of properties for any given application. If you can't sell that product, then you have to back down the requirement of just using the very best materials and see how you can go with something that's good enough. How do you go through that decision making process of selecting something that will not fail prematurely as a product, but at the same time something affordable enough to be able to competitively introduce it in the marketplace. So this property chart in terms of modulus as a function of cost can be useful. In this particular case, if you take a closer look at the x-axis, it is called relative cost per unit volume. Since in a lot of designs, mild steel is often the starting point for consideration, and because of its cost attributes, doing a ratio between the cost per kg times the density of the material and cost per kg times the density of mild steel will allow to get this type of a relative cost estimate, and that's the basis of the x-axis. So you'll end up seeing that for a factor of 1, right, you end up having the low carbon steel or the mild steel, and then anything to the right will be more expensive materials compared to the mild steel, and anything lower than that factor 1, right? So left of this vertical line will be cheaper materials to consider. So you can see the cheap stiff materials. So combination of high E and low cost per unit volume tend to be in this kind of a region. In a similar manner, compared to plotting modulus versus cost, you can also plot strength versus cost with the same type of an introduction of how that x-axis is derived relative to mild steel as the basis. So these guidelines again change according to the actual design conditions based on cross sections and geometry and so on. And so this indices over here change from 1 to 0.67 to 0.5, for instance, for the strength factor. Again, cheap and strong materials lie towards the top left over here. So in this class, to summarize, we have looked at a number of property charts where the x and y axis are varied over a large number of properties, both directly as well as derived as a product of multiple combinations of properties. These help to look at selecting the best material or comparing an existing alternative with something that could be better. So this is the story for week 1 in terms of a background for material selection. On Monday, we'll go through a design exercise that implements the learnings of material indices, property charts, and general properties of materials. There's a quiz 1 that is also due by end of the week on Sunday. So let's look forward to talking again on the set of lectures after the design exercise to take these tools and implement them into material selection.